esse projeto chamado NuCypher. Ele vai apresentar para a gente o esquema do NuCypher de Proxy Re-encryption. A gente dividiu um material aí no comecinho da semana, então eu espero que vocês tenham a oportunidade de ter lido algum material ou pelo menos tido algum tempinho de dar uma olhada nas palestras deles. É um esquema muito seguro de reencriptação. Então, eu vou passar a bola para ele, mas eu gostaria que todos vocês que tiverem qualquer tipo de dúvida, a princípio, se puder colocar no chat enquanto ele explica, tá? Depois a gente abre para um Q&A no final. E qualquer problema, assim, para falar inglês, eu acho que a maioria de vocês consegue entender um bom inglês. É só falar devagar, falar com calma, mas qualquer coisa eu estou por aqui também para ajudar vocês na tradução. Having said that, today we have the presence of NuCypher, one of my favorite projects in the Ethereum ecosystem. What those guys are developing is something very, very unique. NuCypher has a complete different approach to something called Proxy Re-encryption. I don't think you guys have seen something similar in the Ethereum ecosystem or in the blockchain ecosystem. So you will have the pleasure to learn from the beginning, from how the idea started and how is this network evolving. Also, it's important for you guys to know that they were plugged in using the Ethereum network for quite some time, and now they're approaching to launch their own mainnet. So you still will probably have a chance to help the project as becoming a node if you're interested. But I think the idea is that, first of all, you understand the whole idea behind the protocol. They have different personas. So for the first time, you're going to learn that this is not just Alice and Bob. There are two more characters in the NuCypher network. And I am very, very happy to have MacLane Wilkison, who is one of the co-founders, probably the person that first idealized NuCypher. And he is going to explain what the protocol is all about with his own words. So we're going to let MacLane come first. I would ask you guys to please use the chat for Q&A, but in the end, he's also going to be available for questions. Again, if you would like to ask the question in English, great. If not, you can always ask in Portuguese, and I'm going to be here to translate for him. And I appreciate if you could leave your microphones on mute and your cameras also switched off for the Wi-Fi connection. Thank you so much. MacLane, this is with you now.
Awesome. Thank you for the intro. It's a pleasure to present NuCypher to all of you, and thank you for making time and for joining. And I hope that everyone on the call is staying healthy and safe during this very strange times that we're living through. Give me a second to try to share my screen. Oh, it's going to want to share my entire screen for some reason and not just... Here we go. Is everyone able to see my screen?
Yes, the entire screen, actually. Sorry about Google Meets.
Okay. Yeah, for some reason it's not giving me the option to only share a window, so it'll have to be the whole screen. Hopefully. Anyway, thanks again for joining. So I'm going to talk to you a little bit about NuCypher, which is obviously the project that I was one of the co-founders of. And quickly before we get into the network and sort of how it all works, just a little bit about our company. As a company, sort of our mission or reason for existing is to build the tools that allow developers and individuals basically to exercise their right to privacy, particularly in the context of the digital world and digital applications. So we are a cryptography company, and we work on infrastructure for privacy preserving applications. Within the blockchain space, we specifically work on the NuCypher Network, which is the data privacy layer for decentralized applications and other decentralized protocols. It basically allows you to impose access controls, just manage data in your application and control who can and cannot access that data. So the NuCypher network itself, you can think of it as a decentralized threshold cryptography network. So it provides a set of runtimes and interfaces currently around proxy re-encryption, but in theory, any sort of threshold cryptography primitive could be deployed onto the NuCypher network. So potentially things like Shamir secret sharing or threshold signatures or any kind of other threshold cryptography. And basically, you can think of it as a kind of middleware or a set of developer tools. So the network is not something that really an end user would use directly, but it's a set of developer tools that would plug into some sort of application. So for example, let's say you're an Ethereum developer and you want to build some sort of healthcare application or medical application on top of Ethereum and IPFS. Where NuCypher fits is basically you could use NuCypher to control who can and cannot access, let's say, patient medical records. So you're building a health records application and you want to store those records on IPFS or Swarm or some other decentralized storage protocol. You could use NuCypher to allow users to share those encrypted files with a hospital, insurance company, their doctor, etc. And the core technology that we use to power the network is something called Proxy Re-encryption. And what Proxy Re-encryption does is it allows you to take a piece of encrypted data. So in this case, this CA or ciphertext A here, and it allows you to do something called re-encryption, which is this proxy can re-encrypt the data. It could take ciphertext A and transform it directly into ciphertext B. And the magic of proxy re-encryption is that this happens without having to decrypt in the middle. So typically you'd have ciphertext A encrypted for Alice. She would have to decrypt it, encrypt it with Bob's key, and send it to him. But with proxy re-encryption, this re-encryption or transformation can happen as one kind of atomic transaction. So there's no way for the proxy to ever see in the middle, what that plain text data is. And so we fit the web system, use NuCypher alongside sort of decentralized file system like an IPFS or a Swarm or a storage, something like that, and it allows you to decentralize way. And I think it might be helpful to kind of build up to why you would need proxy re-encryption specifically for this. So why couldn't you just use standard vanilla public key encryption? So a lot of you might already be familiar with how public key encryption works, but let's say you're Alice. You have some secret message that you want to send to Bob and to Charlie. So that secret message, generally you keep that encrypted because it's private and sensitive. But if you are Alice and you want to share it with them, if you just send them the data encrypted under your own key, obviously they have no way to access it. So you'd have to decrypt that message, encrypt it with Bob's public key, send it to him, encrypt it with Charlie's public key, send it to him. And that works okay, but obviously it doesn't scale that well. So the more recipients we add, the more encryptions you have to do. And then beyond that, it also is pretty burdensome on Alice. So it requires Alice to always be online. It requires Alice to come online, encrypt data for Bob and Charlie and Dave and Evan and as many recipients as she wants to share data with. So in the Web 2 world, she could just rely on some service provider to do this. So a Dropbox or Google Drive or something like that, where she stores the data. That data might be encrypted at rest, but the service provider will have the encryption key. So the service provider can decrypt that data if Alice wants to share it with Bob, and the service provider can encrypt the data for Bob or Charlie or whoever and send it to them. This places a lot of trust in the service provider, which is fine. I mean, maybe we trust Google, trust Dropbox. Probably a lot of us on this call don't, because that's part of what interests us in Ethereum and cryptocurrency and blockchain. But let's just say, for argument's sake, that maybe that's okay. But in the Web3 world, where our data is not sitting on the data center controlled by Google or Dropbox, in the Web3 world, maybe the data is being stored on that's actually malicious. So that IS node, could be sitting in a hacker's basement or even controlled by a malicious regime. And so the idea of decrypting the data server side is a complete non-starter, because at that point we're effectively exposing the data to anyone who cares to look. And so what Proxy Re-encryption allows us to do is that it allows us to remove the trust in that service provider or that proxy. So it allows us to store encrypted data on some remote node, and then it allows us to share that data with as many recipients as we like by simply asking that remote node to re-encrypt or transform the data into being encrypted under the recipient's key. And so at no point is the data ever decrypted on the server or by the service provider. So the only people who ever have access are, of course, Alice, the original data owner, and whoever she explicitly shares the data with. So Bob or Charlie or whoever, by creating something called a re-encryption key. And that re-encryption key is given to the service provider. In the NuCypher narrative, which was mentioned earlier, we call this service provider Ursula. And Ursula can use this re-encryption key to basically take the ciphertext for Alice and apply this re-encryption key to it and produce this ciphertext for Bob. And so the only thing this re-encryption key could do is re-encrypt the data. It can't decrypt the data. There's nothing sensitive about this re-encryption key.
MacLane, I'm going to add a parenthesis, and I think I'm also going to explain this in Portuguese later. But for the first time, we have a different model, because in all other blockchains, Alice is encrypting directly to Bob. And this time with NuCypher, Alice encrypts with her key to this network of nodes. So for the first time, she is not just sending like data and the message to Bob, but also to a different network. So the key here is the word proxy. Proxy é exatamente essa rede que eles dividem. So the secret is going to be shared, and he's going to explain very shortly how this whole key management is going to work. But this is the first time you're going to see the name Ursula, which comes from the Umbral network. Am I right, MacLane?
Yep, that's right. So Ursula so under the hood, and let me see if I have a slide for this or not. I don't, but I can switch instead to GitHub. So under the hood, the proxy re-encryption algorithm scheme that we use is called Umbral. And we have an implementation of that in Python called PyUmbral. And this scheme is a threshold proxy re-encryption scheme. So up to now, when I've been describing proxy re-encryption, I've assumed that there's only one Ursula. But in fact, the way the NuCypher network works is that there are many Ursulas. And we can actually split this re-encryption key. So we take the re-encryption key that Alice created, and using mathematics very similar to Shamir's secret sharing, we can split that re-encryption key up into many pieces. And then we can set some threshold number of those pieces that are required in order to do a successful re-encryption. So we'll split that re-encryption key up. We'll send those pieces to different proxies in the NuCypher network. And then when Bob wants to access the data, he will ask those proxies in the NuCypher to re-encrypt the key. And if you get sufficient threshold of them, we'll be able to decrypt the data. And Umbral is this threshold scheme. So previous proxy re-encryption schemes only allowed for one proxy, whereas Umbral allows for basically arbitrarily many of them. So we can split that key up and share it among many proxies. So this adds some decentralization to the scheme. It also adds some redundancy. So if some of these nodes are not available or go offline or just aren't responding to Bob, as long as he can get a sufficient threshold of them to respond, data. And so is a library that you can use independent of the NuCypher network. It's on our GitHub at, if you go to our GitHub org, which is NuCypher/PyUmbral, you can find that encryption library. Obviously, we designed it specifically for use with the NuCypher network, but theoretically, you could use PyUmbral independent of that. It has quite a nice, API for a cryptography library. Basically, we use these characters, Alice, Bob, Ursula. We use these characters in our code. So you can see we actually call Alice's private key, Alice's public key. And the reason we do that is it makes for sort of an easier to understand developer experience, in our opinion, at least. Okay, jumping back. So we covered the slide. Another nice thing about the NuCypher network is that you can attach conditions to encryption key. So let's say Alice only wants to share some data with Bob, maybe after a certain amount of time has passed, or only after Bob has paid, 1 ETH to her address, or potentially, based off of some arbitrary smart contract logic. She can attach these conditions to a re-encryption key and tell the Ursulas that are holding that re-encryption key to only re-encrypt if whatever condition that she specifies is met. And then, why should we trust these Ursula nodes in the first place? I think we've covered a couple of the reasons. One, the Ursula nodes have no way to ever decrypt the data, so the only thing they can do with that re-encryption key is to re-encrypt it. 2, the Ursula nodes, or to become an Ursula node, you have to stake the NuCypher, the native NuCypher token. So NuCypher is basically something called a work token, if anyone on the call has heard that term. And what that means is if you want to be an Ursula node, you have to stake the NuCypher token as a kind of bond or collateral. And then we use that to coordinate the network. So if you staked and you're running an Ursula node, you will get work orders from Alice in proportion to the amount that you've staked. So if you staked 10% of all the nodes, of all the tokens in the network, you'll probabilistically get 10% of all the work. And of course, 10% of all the payment for that work. So this is basically you can think of it as a kind of security deposit against nodes misbehaving either maliciously or through laziness. And then to bring it kind of all together, and actually one thing I wanted to clarify, NuCypher is not its own blockchain. So it's basically a layer 2 network on top of Ethereum. So the new token is an ERC20 token, and it's only used to stake. So we get all the functionality that we need from being an ERC20 token and from the Ethereum network. So all the payments are made in ETH. New token is only used as a stake. So if we bring everything together, kind of the way this looks is you have Alice, who will issue sharing policies to the blockchain, Ethereum blockchain, and then she will issue a sharing policy as well to the nodes in the NuCypher network. She'll encrypt some data, and then she'll upload that data to some encrypted storage layer. This could be a decentralized file store like IPFS or Swarm. It could be a traditional centralized file storage like Amazon S3. You can use whatever storage layer you like. And then we'll wait a few days, and along will come Bob. And Alice will have specified in her sharing policy that she wants Bob to have access. So what Bob can do is that he will download the data that's stored encrypted from wherever it's stored. He'll download it, let's say, from IPFS. At this point, that data is encrypted under Alice's key, so Bob has no way to decrypt it. He can't access it. So what he will do is he will ask the NuCypher network, hey, I've got this encrypted data. Please re-encrypt it for me so that I can now access it. And the NuCypher network will take those re-encryption key shares that Alice issued out to the network, and then the nodes will do their piece of the re-encryption. And as soon as a threshold number of those nodes have done the re-encryption, Bob will be able to decrypt the data with his own private key. And I think I heard a chat message, so let me check if there is a... Okay, so maybe I will pause here for 1 second and just make sure that all that is relatively clear, or if there are any questions, please feel free to either put them in the chat or ask them. Okay. So yeah, just to recap, these are basically all the characters in the NuCypher network. So we have a few that are, very familiar. If you're, in cryptocurrency, you're familiar with cryptography. You've got Alice, who's the data owner. You have Bob, who is the data recipient. The new characters that we introduce are obviously Ursula, who is the proxy who's doing the re-encryption. And then we also have a character called Enrico, who in the traditional cryptography narrative, Alice and Enrico are sort of one and the same. We've just kind of separated the role of Alice, who's the data owner and who has the ability to issue re-encryption keys, from Enrico, who's the one who actually encrypts the data in the first place. So in many use cases, Alice and Enrico are one and the same. So if you were using NuCypher, for example, to share, let's say, an encrypted, iPhotos or something like this, and you wanted to share your photos with your family or friends, Alice and Enrico, you would effectively be an Alice and an Enrico. But in the app, these case where, let's say you're sharing, you've got a heart rate monitor or an Apple Watch, your heartbeats with your doctor, you, like the individual who's wearing that watch, be Alice, but your actual watch generating, encrypting the data might be the Enrico. So we just split these two roles and these two functions because we thought it made it a little bit easier to reason about different use cases. So that's basically like an overview of the network and the architecture, and I'll kind of move into a little bit more about where we are in terms of time, and how you can get involved if you're interested in the project, either from a staking and node operation standpoint or from the perspective of building an application on the network. So right now we have a testnet running on the Goerli Ethereum testnet. You're able to basically get testnet tokens from the faucet in our Discord, which actually is NuCypher.com. You can join our server, and there's a testnet faucet channel where you can get testnet tokens, which you can use to stake and to spin up a testnet node. And you can just follow the instructions in our docs. If you go to docs.nucypher.com, we have some guides that explain how to do that. We are also network on Ethereum main. So we finished our incentivized testnet, which was kind of the final stress test before mainnet, making sure that everything was polished and working stable, sort of at a large scale in terms of number of nodes. So the next step for us is to launch on mainnet, as well as do our public token distribution, which is using something that we created called the work lock. So you can think of the work lock as basically a replacement for other types of public token distributions like ICOs or IEOs or airdrops. But it's targeted towards people who will use the token in the way that it's meant to be used, which is to stake and to run a node. And what the work lock allows you to do is effectively to stake ETH and earn NuCypher tokens from running a node. So the way that it works is you can escrow your ETH on chain in the work lock contract, and then you'll get back stake locked new. And the only thing you can do with this stake locked new is stake it and run a node. And if you do that, eventually the stake locked new will unlock. You'll be able to transfer them or keep staking or do whatever you want to do with them. But you also get back all of the ETH that you escrowed. So I think if you are kind of a DevOps person or you run nodes for other networks, I think the work lock is like a very good opportunity to effectively, just for the cost of your time and resources of running a node, get NuCypher tokens without having to purchase them. It's also permissionless, so you don't have to sign up on some web page and give us all of your information. You just you escrow your ETH and you get NuCypher tokens, and we are not involved in that process at all. We have a blog post that describes the work lock from when we formulated it a couple years ago. And then we also have a guide on kind of the mechanics of how it will work. And we don't have a hard date for when everything will start, but sort of current expectation is the work lock contribution period will start sometime towards the end of either April or early May. And that it will run for about 2 to 3 weeks, during which you'll be able to escrow your ETH. And then the contribution period will end. All the tokens will get distributed, and mainnet will start immediately after the work lock contribution period. So interested in possibly running it, what I would recommend is get a feel for it, get the tokens from the faucet, and if you're comfortable and if you want to run a node on mainnet, look towards the work lock distribution as a good way to do that. And then, of course, the other major way to get involved with the network is to build some sort of application on top of it. We have a couple hackathons that we're likely going to be participating in coming up fairly soon. So there's a bunch of given everyone most of the world are on lockdown or in place, there's a bunch of virtual hackathons that are getting organized right now that we're probably going to participate in. And so those could also be a great way to build an interesting application on top of the network, learn how it works, and if it's an interesting application, potentially qualify for some prizes and get paid for that. If you want to build something, our docs are also the place to start. We have guides specific for either running a network node or building an application. We also have a work lock guide. But if you're wanting to build something, obviously application development is the place to start. We have a section on understanding how to use the different characters in the network. If you're using the command line, how to control them. Also, if you're using if you want to call them from like a web app or some other sort of app, we have character control that you can do that with. But in any case, if you go to our docs, there's guides for the different ways to engage in the network. And I think the best way, and most of our community is on Discord. So if you're interested in either of those, either staking, running a node, or building an application, definitely hop into our Discord channel. Our company is fully remote, even before all of the COVID coronavirus stuff. So there's always usually someone in the Discord that's willing and able to help if you have technical questions, either about running a node or building an application. There are teams kind of all over the world. So usually at any time of the day, there's at least one of us in there. And I will that's like the bulk of the content that I had. Definitely happy to answer any questions, or if there's certain aspects of the network or the system that are of interest to everyone on the call. I'm happy to sort of dig into any of those in more detail.
Thank you very, very much.
Oh,
And it was like a very wonderful overview about all the what the project can do, how can people get connected. So I would like to open up for Q&A from the audience. What would you guys like to ask? And please feel free.
Oh, and Juliana, I see you had a question. Does Enrico see ciphertext or real data? So Enrico is basically the character that encrypts the data originally for Alice. So as I was describing in like the previous examples, in most applications and in most use cases, Alice and Enrico are actually the same. So if Alice, if it's a photos application, you're sharing data, or sorry, photos with your family, you get an owner, and you're also the one encrypting the data originally. In some applications, there could be one Alice and many Enricos. So let's say your watch is generating heart rate data, your phone's generating browsing data. You're Alice, the data owner. You own the data that's being generated by both of those, but your watch and your phone are the Enricos. So Enrico is trusted in the sense that it, in many cases, is generating the data and it's encrypting the data originally.
I see. I think I got confused. Maybe it's then the Ursula network that receives ciphertext only, if I'm not wrong.
Correct. Yep. So Ursula does the re-encryptions, and she never sees plain text data. She only ever sees encrypted data. So you don't have to trust Ursula in the sense that she never has access to the data.
I'll make a parenthesis to explain also Shamir secret sharing, because that's exactly how this information gets broken down into different pieces. Pessoal, não sei se vocês já ouviram falar de Shamir secret sharing. É um esquema de divisão de um segredo. So, in Shamir secret sharing, you actually break a secret into different pieces. And all those pieces are encrypted pieces. So when you receive a piece, imagine it's like a puzzle, é como se fosse puzzle. You receive only a piece with gibberish. Gibberish is information that you don't know what it is. So you receive ciphertext. And then to decrypt that information, you need the majority of these pieces together, and then you can decrypt it. So they usually say M out of N nodes, meaning if you have divided the secret in 11 parts, you need the majority. So if you have 5 people together, they're not going to be able to decrypt. If you have 6 people together, they're not going to be able to decrypt. You need 7 nodes to be able to decrypt that. So you usually need 3 out of 5 or 2 out of 3. So this is the scheme of Shamir secret. You don't need all of them to decrypt and read the secret, but you need the majority of the nodes. So I thought that Enrico could only read the ciphertext, but actually Enrico gets the data, breaks it down, and then only ciphertext goes to the network.
And in my understanding, do you encrypt once with pub key Bob, but send to Ursula? Why not send direct to Bob? Yep. So actually, the way that it works is you encrypt once with Alice's public key, and then you store the data, and then create arbitrarily many re-encryption keys for as many recipients as it takes. So there's a couple reasons why proxy re-encryption might be preferable to just encrypting the data and sending it directly to Bob. It's not, it's not better in every case, but the scenarios where it's better are if Alice doesn't want to be online, So in the case of Alice encrypting for Bob and sending it directly to Bob, obviously Alice has to come back online to do that. And if later on she wants to share that data with Charlie or Dave or Evan, she has to come back online, download the data, decrypt it, encrypt with Charlie's key, Dave's key, whoever's key, and send it to them. Whereas with Proxy Re-encryption in the NuCypher network, Alice can encrypt the data one time. She can create re-encryption keys for whoever she wants to share that data with in the future, send those re-encryption keys to the network, and then Alice can disappear entirely forever. And the data, let's say there's an Enrico that's continually producing data, that data can get shared on to Bob, Charlie, Dave, Aaron, without Alice ever having to come back online. So it's more scalable because this re-encryption is cheaper. It doesn't require Alice to be online. And then the other benefit is that she can attach conditions, and she can also revoke access. So let's say Alice decides that she no longer wants to share the heart rate data that she's generating with her doctor. So she can issue a revocation request to the NuCypher network and say, hey, please stop sharing all of my data, or revoke access from my doctor to all of my heart rate data. And the Ursulas will basically stop re-encrypting any of that data for Bob. So you have a few of these benefits here. And then there's another question about homomorphic encryption from Talita. And yes, we do work on, we do have a fully homomorphic encryption library. It's not part of the NuCypher network right now. I don't know what will happen, but right now, homomorphic encryption is kind of a research area for us. And I can explain really quickly what fully homomorphic encryption is for anyone who doesn't know. Let me share my screen again. So fully homomorphic encryption is a type of encryption that allows you to still process data while it's encrypted. So the point of encrypting it is to obfuscate or hide the contents, like the plain text data. And when you encrypt it and you obfuscate it, that basically destroys any pattern or any ability to know anything about the data. But what homomorphic encryption allows you to do is to still, even though the data is encrypted in principle nonsense, it allows you to do certain types of, well, in fully homomorphic encryption, any kind of arbitrary function on that data and get a result. So in the same way that you have plaintext data, you apply a function to that plaintext data and you get some result. With fully homomorphic encryption, you can take some encrypted data, apply a function to that encrypted data, and then get an encrypted result. So this has a lot of interesting applications, particularly in like the context of cloud computing, where let's say there's some, you want to use Amazon Web Services or Google Cloud or some cloud provider to analyze or process some data, but you don't really trust that cloud provider, or you don't want to expose the plaintext data to that cloud provider. So in principle, with fully homomorphic encryption, you could encrypt the data before you upload it to the cloud. Then you could upload it to the cloud and you could run whatever machine learning or whatever kind of analytics you want on top of that data. Now in practice, you can't really do that now, because at least in a practical way from those use cases, because fully homomorphic encryption is very, very slow. And what we've done so far, we've done some other stuff that we haven't released yet, but the main sort of public piece of work that we have around homomorphic encryption is our library called NuFHE. And that's also open source on our GitHub that you're free to play around with if you like. And what NuFHE is we took one of the existing schemes called TFHE, and we accelerated it with GPUs. And that got us about 100x performance improvement over just using a plain CPU. But even then, it's, as you can see, like for most of the sort of like really compelling or really interesting use cases that you probably might be able to think of for homomorphic encryption, is still quite slow. But there is this library. As far as I know right now, NuFHE is the fastest fully homomorphic encryption library that's available. It is very much like an experimental library, so it has not been audited. Like, I don't necessarily recommend that you use NuFHE in production, but if you have a GPU and you want to experiment with it, you certainly can. Just grab this off GitHub, and you have fairly good docs for it. So you can certainly play around with it. I'd encourage you to do so. We all have in our Discord, we have a channel for HE, where we can also, provide technical support, or if you have interesting use cases for FHE that you'd want to talk through, we'd be super happy to chat with you there. And there, the docs for NuFHE is just nufhe.readthedocs.io, which is also linked here from the GitHub. And then, is it for the IoT device, Manuel? I don't know if that was referring to, maybe if you can sort of expand on your question a little bit. And then the question about gas costs on Ethereum and whether it's efficient on an embedded device. So one thing that I think I didn't really clarify that well in the presentation is that all of the re-encryption stuff is happening off-chain. So all the Ursula re-encryptions are happening off-chain. Obviously, when Alice issues a policy, she sends that policy to the Ursulas, and then she also does an on-chain transaction as a kind of payment for the policy. So Alice does some on-chain work. All the Enrico, where he's encrypting data, that's also, of course, off-chain. So Enrico could be an IoT device that's producing data and encrypting it. But the actual re-encryption, like the bulk of the interesting stuff that's like happening at a cryptographic level, is not happening on chain. So obviously Alice has to pay gas costs for the payment transaction. The other piece that touches the blockchain is if one of the Ursula nodes is misbehaving, there is a challenge protocol where certain types of misbehavior could potentially cause the Ursula to get slashed. And that challenge protocol also happens on chain. But we try to minimize sort of the touch points with the blockchain, just because, obviously there are scalability concerns, but also like we really just use the blockchain to coordinate work and to ensure that Ursulas are behaving correctly. So we don't really need to do a whole lot on chain.
Any more questions? Just unmute yourself, please, and you're free to go.
Hi. My question related to IoT device, that if I have an IoT device producing data that I would like to sell to Ford, for example, I authorize this device, and Ursula pays me for the data that I am selling to Ford, but she doesn't know that that is my data that she's paying for it. And Ford, when I receive the data, decrypt the first data and know that it's from me. Is that what you can do with this thing?
Sorry, it was breaking up a little bit, but I think the question was, you have an IoT device that's producing data and encrypting it. So in this case, that would be effectively an Enrico character. And then you want to sell that data to some Bob. And you only want Ursula to re-encrypt the data if Bob pays for that data. And then I guess the question is, like, how does Ursula know what data to re-encrypt, or what data is yours that's meant to be re-encrypted?
Yes.
Got it. So we have, let me see if I can find it that easily. Actually, I think we have an example on GitHub that maybe can show this fairly well. So in NuCypher, we have this concept of data labels. And so each basically discrete piece of data that might get re-encrypted will have a label. And you can kind of think of a label as like a directory structure. So Alice might have a bunch of different sort of data sets that she's using NuCypher to manage permissions on. So she might have, photos, she might have, work files, personal files, heart rate data, basically music, a bunch of different things. And then she wants to share some of that data with a certain Bob. So let's say she wanted to share her heart rate data with Dr. Bob. She doesn't also want to share her, music and her photos with Bob, just the heart rate data. And that's where the concept of labels comes in. So each of those different data sets would have a label. And when she creates a sharing policy, as part of that policy, she will basically inside the re-encrypt key, effectively, she will specify which label is meant to be shared. And she'll create re-encryption keys for each of those labels for each recipient. So she would create a re-encryption key that applies to the heart rate monitor label for Dr. Bob. And Dr. Bob would only be able to get that heart rate data re-encrypted if he somehow got her encrypted music line. There's no policy in the net, or there's no re-encryption key will re-encrypt that music data for Bob. So he'll basically just see encrypted gibberish. He'll have no way to get it re-encrypted. Let me see again if I can find the example that I think does this fairly well.
I can't see your shared screen right now.
Yeah, 1 second. Okay, so this file is just on our main GitHub repo. If you go to NuCypher, examples, heartbeat demo, alicia.py. So this is actually that exact example that I was giving, where you have Alice. You have an Alice. She has a heart rate monitor that's producing basically heart monitor data, or generating heart rate samples. And the way that she shares this data is she will label that heart rate data. She'll create a label for that data. And then she will, for each label, there will be a different key that encrypts that data. So she'll use a different key to encrypt her heart rate data than she will use to encrypt her music library, and she'll have another key that will encrypt her photos, etc. So each label is encrypted under a different key, right? And then when she wants to share that data with Bob, or Doctor, she will create a re-encryption key. She'll create a re-encryption key using this sort of grant function, specify the recipient, who's Dr. Bob, specify the label, which is the data that she wants to share, and then whatever threshold she wants to split the re-encryption key up into. And then this is just another condition where she only wants to share the data for some set period of time. So long story short is, each different type of data set that Alice has, she'll encrypt with a different key. is how we have that separation.
Okay, thank you.
Mais perguntas, pessoal? Please enjoy. This is only once a month that we have this quality content, which is such an impressive and different scheme of cryptography. So don't waste this opportunity, please. If not, I'm going to ask. MacLane, I think that one of the biggest use cases of NuCypher is actually medical sensitive data. I've seen like many examples using medical data in NuCypher's network. So the first was the heartbeat demo, but people are very protective with their medical records. Do you think that this is the main use case, or what other kind of data do you think people are using NuCypher's network to protect?
Sure. So obviously, healthcare data is a very compelling one. It's easy for people to understand. They understand why it's it's sensitive. There are definitely a lot of healthcare projects, whether they're medical records projects or sort of genomics projects in the blockchain space that are using the NuCypher network as a way to share access to that data. And that takes a couple different forms. So obviously, like the medical records case is obvious. You need to keep your medical records private and confidential, but potentially share them with a healthcare provider. There's also some interesting projects that are working on things like kind of like decentralized 23andMe, where you can upload your encrypted genome and then effectively grant access to a researcher, but they have to pay you first. So kind of like a data type marketplace type of thing. There's also, but it's not limited to healthcare. I mean, we are part of the MOBI initiative, which is a consortium of blockchain consortium for auto manufacturers and different mobility companies. So that are looking, how can they use blockchain in the other space, potentially around like, and NuCypher could plug into that, where these cars need to share potentially data with each other. There's also a good sort of list of some nice sample applications from this hackathon we did last year with CoinList. So I just put that link in the chat, and if you look at, there's probably 20 or so projects there, and that can give you kind of an idea of like the types of things that people are building with NuCypher and sort of what's possible. So there's everything there from like a genome data marketplace to an encrypted chat sort of Facebook thing to an encrypted decentralized Dropbox using NuCypher. So there's quite a range of things that people are interested in potentially using NuCypher to build.
That's really, really nice. Thanks for sharing. I think like we're developing, there's a team in this consensus health hackathon happening this month with Gitcoin. And we thought about using like the zero knowledge proof scheme to protect the data of a person that was like tested positive with COVID, and now they need to like prove that they have the antibodies. And we decided to go for zero knowledge proof. Would you like compare or like say that it's a better scheme to share sensitive data using zero knowledge proof, or they're completely different monsters? There's the use case is completely different than proxy re-encryption.
Yeah, so I think that it definitely depends on the use case. The use cases are fairly distinct. Kind of how I would think of it is, if you need to share the actual data with someone, proxy re-encryption is a good fit, because let's say you are doing some sort of telehealth consultation with your doctor. Obviously, you don't need to prove certain things about your health to your doctor. You need to like actually share, the data so that the doctor can look at it and analyze it and give you recommendations off of the data. Whereas if you need to prove some property about the data to someone, so let's say you need to prove that you don't have COVID in order to go out, I guess, of your house, and that you have like the antibodies for that. Maybe a zero knowledge proof thing would be a better fit. But I think basically the way to think about it is, does this person need access or not? If they do, proxy encryption is a good fit. If they don't, they just need to know something, property about the data, then zero knowledge proofs probably are a better way to do that.
Great.
But in many ways, I think I could imagine also applications where you would use both for different aspects of the application.
Great simplification. I think like you just nailed it. Like if you actually need to share, then proxy re-encryption it is. Whether if you just need to prove you're a certain age or you have like you can perform a certain calculation, then zero knowledge is more the use case. So many people joining now, about 1 hour that we just started the call. Guys, we started the call at 6, so I'm very sorry, but this is recorded. MacLane explained the whole NuCypher scheme. I would still open for more questions if there's some more from the audience. And please feel free to unmute yourself and ask.
Sure, yeah, happy to answer more. Or if there are questions you think of after, definitely hop into our Discord, and either myself or someone else on our team, I'm sure, we'll be very happy to answer them there.
Lembrando, se alguém quiser fazer uma pergunta em português, eu posso traduzir também, o que for mais fácil aí, pessoal. Are you guys enjoying? Did you learn something new today? How did you like the presentation so far? Well, I think this silence is like the beginning of our end of our presentation. MacLane, once again, I really appreciate you to take time to explain in very, very easy way this proxy re-encryption scheme, presenting the whole token, how do people actually can contribute by becoming a node, all the challenges that NuCypher went, and even full homomorphic encryption, which was a bonus. So I really appreciate. It's a project that I will still follow. And I suggest everybody here to go to their Discord. That's where you can learn a lot. There's a lot of very good documentation, not only on GitHub, but on their website, NuCypher.com. And they're very welcoming as well to Q&A. So I think like the best way is even go to Discord and read what people asked in the past. But once again, in the name of Ethereum Developers Sao Paulo, I appreciate your time for being here with us. And I hope the community could learn something new that never comes to South America.
Absolutely. Thank you so much for having me, and I hope everyone enjoyed it. Hope everybody stays healthy and safe, and thanks so much.
Thank you. Bye.
All right. Bye, everyone.